Let's start out by making a phone class. And let's think of pieces of information that you would have, that the phone company would keep. And let's go back to the days when you had those phones that they put on the wall. Remember those that were attached? Just as a starter point, though. So we're talking old style phone here that maybe your great grandparents had, right? So the stuff that they would keep would be private string name, and what other piece of information would they? A phone number. So we'll keep that as private string number instead of an integer, since it's got a dash in the middle of it. And so let's make a constructor. And while we're at it, I guess we should write the getters for it at least. Got it. And let's go and make a main program. It's going to actually use one of these phone creatures. And we'll just make a phone. One of these days I'm sure I'm going to get sued for using this name. Okay, and let's also go back into phone and let's put maybe one other additional piece of information. If the phone company is trying to track how much you're using the phone, normally they would have done it for long distance, but they also sort of keep local talk time too. So we'll just put an int in here for talk time, whatever it happens to be. And we'll add in a public int get talk time. And talk time needs to start out at 0. And we'll need a public setter that does something. And so if they talk for some number of minutes, then talk time that many minutes. Okay, so there's a phone class. So now we can do something like we can say my phone dot talk for 10 minutes, and then we'll call it talk.
Up the top there, shouldn't your
Talk.
second string be a number?
No.
In the driver?
Oh, in the driver, no, I'm going to use, oh, sorry, yeah, you're right, thanks. So it's Fred's phone, and that should be some phone number, thanks. So we'll talk for 10 minutes, and then we'll talk for another 20 minutes, etc. And then we're 30 minutes, and then we could do something like print out. Don't worry, it gets exciting pretty quickly. Just have to get the basic one done first. Something like that. Okay. And there's your basic phone. doing its thing. Okay, so now let's suppose that we move up in technology and somebody comes along with another newfangled kind of phone, the ones without the wires on them. What are they called?
Cellular.
Cell phones?
Portable.
So if we wanted to do a cell phone class, we would start out and we would say cell phone, let's make a cell phone class. What sort of information would you put in the cell phone class?
Same data.
Still be name, number.
Exactly the same stuff, except what's the difference with a cell phone in terms of how talk time operates? What's the key thing that happens with a cell phone when you go buy a phone plan? Usually you have some number of plan minutes, right, for local talk time or whatever. So that's been the characteristic of cell phones for quite a long time. So a cell phone is like a regular phone, except it's got a plan attached to it with a certain number of minutes. And so we would have all of the same sort of data that we had for phone. So I'll just make the point here by cutting out all of this stuff and putting it in here. And plus we would probably have planned minutes so that they know how many minutes there are in your plan and they can start to charge you if the talk time for the month ever exceeds those minutes. Okay? And so in here we would have public int get plan minutes. Like so. What would the constructor look like? So it would have that extra argument to say this one's somehow different, right? It's got that extra argument. And I'm not going to fill that out for a second. And so if we go back and just try to use this thing in the driver, what it's going to look like is when we make our next phone, it's going to be a cell phone instead of a regular phone. And it's not only, it's going to have Barney's number, and in addition, Barney might have something like 200 minutes on his plan. Okay, so there's another phone. Okay, but notice that the issue here is that we basically did all of the stuff that we had for phone, and then we just added this one little piece of information. Here comes the Java trick. What we'll do here is we'll just delete all of this stuff, and on here we're going to say extends phone. Okay, and you can think of extends as meaning adds to. So take all of the stuff that we've already got from phone, all of those variables, and we're just going to plop in the extra stuff, right? So those other variables are now still there in the phone class. All of the functions, the methods are still there in the phone class and usable. We've just added extra stuff. Okay? And the only special thing that we have to do here is we have to get those other variables in the phone part of the thing initialized properly. And so you would think that that's phone dot, I'll do it this way. You would think that you could call the phone constructor and say, we'll pass in name and in number to the phone constructor to let it initialize those things, because it's sort of buried inside of us. And then all that we'd have to do is set plan minutes to in plan minutes.
So is that pulling the variables out of phone and we use them independently, or is that affecting the variables in phone?
It's as if we'd sucked the entire phone class inside of this thing so that we now have all of those phone variables and all of those phone methods. So, I mean, the other way of thinking of it is it's literally as if we'd taken this whole piece of code here and turned around when you say extends and pasted it into this piece of code.
But they're still used independently from each other?
You can use phone independently, but you can't use cell phone independently from phone because phone is built into it now. So it really means adds to. You get all of the stuff that you had in phone, plus you can add more stuff to it, so you get to build on what's in phone already rather than starting from the beginning. Is all that's really happening. Okay? So this is sort of what we'd like to say. The idea that what this is doing is we're going to call the phone constructor to do the initialization for the variables that it has buried inside the phone class. That'll call that constructor. And then afterwards, the only thing that we've added is plan minutes, so we'll make sure that our plan minutes variable gets initialized. That's sort of what you'd like to do. The only problem is that Java, for some reason, rather than using that syntax, decided to use a totally different word here to mean the phone's constructor. And the word that they use happens to be the word super, as in the class above us for some reason. And so this is old terminology. But the easy thing is every time you see the word super in one of these classes, all that you have to do is go look up here to that word that says adds to, and that just substitute the word phone in for super, and that's exactly what it does. So that's really calling the phone's constructor to do the initialization. Okay, so now just this will make the thing just a little bit more clear. If we go into the driver, let's just watch this here. Barney, so Barney is a cell phone. Notice what happens when I hit the dot. Even though the cell phone doesn't have any code that shows get name, get number, etc., that's coming from the phone class because we said we're adding to the phone class, so we get all of those methods for free because they're built into phone. And the dot says you can use them. So now it's perfectly legal to go have Barney talk on his phone for some number of minutes. And it's also perfectly legal to print out Barney's minutes using the getter. And this is Barney.talktime instead. Okay, so we'll run the driver, and that still works. We'll make this clear that this is Barney versus this is Fred. Run it, did I? There we go.
Is there a way I can pull the variables out of phone all but let's say one of them?
No. You get
All or nothing?
you can choose not to use them.
Oh, okay.
That's fine. So there's no reason why you have to use them at all, but it's perfectly logical in this situation because you're basically saying, hey, look, a cell phone is just like an ordinary phone, except it's got this extra stuff in it, this extra amount of information that we're trying to keep. And that's exactly the way you think of it in real life. Oh, a cell phone is just like any other phone, but I had to pay for talk time for this thing that I didn't have to pay when I was making local calls on my other phone. one on the wall.
What if Barney had a regular phone?
It's got nothing to do with Barney. It's just like if Barney had a regular phone, then it would be Barney's regular phone equals new phone.
And then
You just can't use the same variable.
how would you add time to it?
I'm not sure what you mean by adding time. Barney could have two phones. This is actually Barney's cell phone. And if you wanted, Barney could still have a regular phone, but it's a different phone. I mean, it's physically a different phone. And it still belongs to Barney, but it has a different phone number. So it's a different object because it's a different physical object, different kind of phone. So they're not related at all. One's a phone, the other's a cell phone. Okay, so don't let the name confuse you there. That's just the name of the variable that's remembering the physical object. Okay, well, let's talk about, let's put a toString in phone. And let's fill in some of the values. So there's all of those values for the toString there. And let's see what happens when we go to the driver and we'll just call it toString. So we'll print out Fred's information, or my phone first. So if we just do a regular printout, there's all of Fred's information now coming from the toString. What do you expect to happen if you print out Barney's information? Doesn't have any information about his plan. Well, it's using cell phones toString, right? But the problem with cell phones toString is that it was built first and it has no way of knowing, or phones toString is what we're using, and cell phones uses that one, so it doesn't have the additional information in it. Okay, so here's what we'll do. We'll go back to cell phone, and we'll write a toString in here. Now, got the sort of the obvious choice would be to say we could just steal all the stuff from phone, right? Copy all of the information that's already here in this toString, right? Start with that one, copy and paste it in. Or we can just make use of the values. So the way that you can do that is we can use our friend super here again. So the super there means go call the phone's toString, which will give us all of the information for the 3 variables that are already in phone. And then what we'll do is we'll tack on our information for plan minutes. What did I miss? Return statement. There we go. And now we'll turn around and run it. Okay, so I borrowed all of the stuff that was already available in the one below it, and now I've added 2 to get just the additional information. So this is really pretty typical for this sort of idea of inheritance, that you let the parent class take care of its variables, and then your job is to add new variables and do your work only with them. And you can always get at the parent stuff by saying basically parent dot whatever function you need. Okay? And so this class stays fairly small, but it's stolen all of the stuff from the other class in order to use it and make use of it. So it really is that whole idea of adds to. Okay? And here's where that at override idea now comes into play, because you can see that what you're trying to do with this toString is hide the toString that's in the phone class, so that you can get that one called in the driver yourself, so that this call to barneycell.toString is the one that's in the cell phone class, because you're trying to hide the one in the phone class and not show it to people, but use it if you need it. And so what it does is it just works from the top down in the classes. As you establish your hierarchy, it just looks for, is there one in the cell phone class? No. Okay, well, let me see if there's one in the phone class. Yes or no. Oh, if there's not one there, let me use the default toString. Okay, so the one in the phone class, why we've been writing at override on the top of this toString, is because it overrides an existing one. Okay, so that at override there is to say there's already a toString that's lying around someplace. We're going to write our own to hide that one. And now cell phone comes along and says, well, that's fine, but I need a special one, so I'm going to hide the one that was already given to me in favor of one I write myself. Okay, so there's cell phone. Let's do it one more time. What's the kind of phone that you give to children so that they don't use up too much time? No, 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 no. You want to restrict the amount of time that they use so they don't.
Yeah, exactly. Call home, emergency.
So you've got the next level up is the next another kind of phone they introduced is a pay-as-you-go phone, right? Okay, so let's write the pay-as-you-go phone class. So here's the pay-as-you-go phone class. What kind of phone is it? It's a special kind of cell phone, right? So notice that the word that you're using is, it is a kind of, right? You're not using the word it has wheels or it has things associated with it, right? So the rule here is if you find yourself saying, well, it's just like this type of thing, but it's got this extra stuff, then this style of coding is going to work for you. Okay? So a pay-as-you-go phone needs to extend cell phone because it's a special type of cell phone. Okay? And we'll just see what it's complaining about there. Oh, we just haven't done the constructor. It forces you to write the constructor to do the initialization. So the very least that you have to do here is call super with some information. So a pay-as-you-go phone, what sort of information do you supply to it? If you go and you buy one to get it set up. It still needs a name.
Service providers?
In name. It still needs a number. When you first buy your pay-as-you-go phone, how many minutes come with the plan? 0 minutes, because the trick with pay-as-you-go phones is that you have to buy minutes in order to get minutes onto the phone. So it initially starts out as 0. So what happens here is it's a cell phone, so we can pass in name and in number to initialize that portion, but it's a cell phone that has no minutes in its plan. Okay? And so we might have a variable here called something like paid minutes. And paid minutes would start out as 0. And when you buy more minutes, then paid minutes goes up by that number of minutes. Okay, so that's what by minutes does. What about the toString? Well, we won't worry about, we'll leave the toString for a second. Here's an interesting one. What happens when you talk on the phone? The minutes go down. So it's different from a regular phone. In a regular phone, when you talk on the phone, the minutes go up. Right? But in this case, the minutes go down. So what you can do is you can write public void talk, and the plan here, to be specific, is that what we're trying to do is we're trying to override the existing talk in the cell phone to change its behavior. Okay? So in this version of talk, when you talk for some number of minutes, then paid minutes goes down by that number of minutes.
Do they actually keep track of those separately?
Well, the other variable just isn't used. So we've still got a variable in cell phone for plan minutes. Plan minutes still gets dragged into the pay-as-you-go phone. It's still there just like all the other variables, but in this case, we're probably just not going to use it.
So why not just use the same toString from cell phone and 5.2?
You could, now here's a choice. You could do, there's 2 ways that you can play this game. One way is you can make a separate variable like we've done here. The other way is to turn around and set and use plan minutes and then make plan minutes go down. And it sort of depends, you know, what logically speaking makes the most sense. You know, we'll do it the other way if you want. We wouldn't have this variable in here. All that happens when you buy minutes is plan minutes would go up. Ooh, paid minutes we don't need anymore. Plan minutes would go up, and then when you talked, plan minutes would go down. Okay. Notice what's happening here with plan minutes. Plan minutes is in the cell phone class, but it's not letting us get at it because it's marked as private. There's a special word here, a nice new keyword called protected. And protected says it's private except to people who extend it, and people who extend it are allowed to use it. Okay, so notice now that it's protected, it's saying I can go ahead and use it. Okay, so it's halfway in between public and private. Best way to think of protected is think of the keys to the family car. Okay, the keys to the family car are not private because there's more than one person within the family that owns it, but they're not public either because nobody can, it's not just anybody that can come in and use it. They're only available to members, the keys are only available to members of the family. Okay, so that's exactly what protected does. Since you're a member of the family by this inheritance thing, you're allowed to use those variables that are available through inheritance. Okay, any problems with that? Think control.
You might have a value in a sub-level which can access it when you don't want to if it's protected.
Let's talk about the family car for a second. Officially, it's okay to put the keys to the family car onto the wall and say, hey, 16-year-old, you just got your license. You go ahead, it's the family car. You go ahead and use it if you want, which is what protected says. Okay, but yeah, you're grimacing because you know that's probably a bad idea. Usually what happens with the family car when you're a 16-year-old is that you still have to ask your parents for the car, which means you have to do the same asking that somebody outside the house would do, because that still gives the parents the control over making sure that the car gets allocated and used properly. Okay? So the problem with the protected keyword is that it's a nice idea, but it has exactly that same bad effect. That as soon means that you lose control inside this class because anybody else who comes along and extends it can play with the variable regardless of the rules that you've set in the setter. Okay, so the other alternative here is to not use protected, leave it as private, and make the class that extends go through and use all of the getters and setters that are provided by the previous class in order to manipulate the variables that belong to the previous class. Okay, and so in general, that's probably the better way to go. Okay, so I wouldn't necessarily do the protected thing here, but it's worthwhile seeing the facility to know how it fits into the big picture. Okay, and so now what would happen with this thing is that we would turn around and we would modify the toString to get the information that we needed. And it might be that this is a custom toString because in this case, we don't want to add to all of the string that's already there. We actually probably want to take away the fact that there's plan minutes maybe or whatever. So we may or may not use the toString directly. So the point is you can always call the getters to retrieve the information out of the other class, make your own toString regardless. You don't have to use the one that's provided already. Okay, so there's a sample of doing inheritance. Okay, now here's the interesting thing about inheritance is that it actually occurs not very often in real life. And one of the symptoms of that is that if you go look at any Java book that's been produced in the last 15 years and you go try to find an example of inheritance in the book, every book uses almost exactly the same example because nobody can think of another one. So the one that you'll usually see is, I call it the mammals example, like you've got your, the Linnaeus hierarchy of animals. You've got your animal and it could be, the warm-blooded animals that could, where you divide up in inheritance that way into the big hierarchy. That's one example that they tend to use. The other example that you see over and over again is the bank account example. So you can have a savings account where you earn a certain amount of interest. You know, you've got your basic bank account, you've got your savings account, or you've got your checking account that allows you to write checks. They're all specific kinds of bank accounts with features either added or taken away. So you can start out with a base case of a regular bank account, which is the basic information, and then make your other bank accounts the specific ones that add or subtract from it. Those are about the only two examples that you ever see in books, okay? This is the only other example that I've ever been able to think of where I go, okay, this actually makes sense to people to see it laid out this way, okay? Because when you see this, people just automatically get it, okay? The place where you will see it used a lot is in the GUI type applications, okay? Because for instance, they'll have a button class, and a button class just puts text on top of a button, right? So they'll make a basic button class, and then somebody will say, well, okay, I want a button class where you can have an image behind the button. And so now you get the image button class that extends the basic button and adds the facility to place background images on the button underneath the text, okay? And so in that sense, in that graphic sense, you'll see people tend to use a lot of that sort of building capability, okay? But those are probably the few instances where it actually takes place, okay? So the basic rule here is really simple. For 90% of the time or 95% of the time, we're gonna write classes we've always done. A dog has got 4 legs, right? So it's this property of a dog, right? So it's things that you wanna keep inside a dog class because they just all relate together, okay? And you always add more variables inside a class. Occasionally we'll have this idea for, it's just like this other thing, only a little bit different, okay? And so then that's the case where inheritance sometimes makes your life a lot easier, okay? And that's basically all there is to it. Extends means add to the stuff that's already there. Now, here's the part that you haven't quite seen before. If we go to the phone class and you look at what happens with phone here, phone, when you write class phone in Java, the compiler actually sticks in extends the big O object class. And so this big O object class is the root of everything that you start with. And it comes pre-fitted with a bunch of stuff already, okay? Which is why when we type a class and then you type dot, it's like all of a sudden you get all this extra stuff and you're wondering where it came from. So let's go into the driver here for a second. And we'll just type something like my phone. I mean, you've always wondered, well, hold it here. There's all this other stuff that we didn't write that somehow seems built in that I've never seen before, right? It's got not only our methods, but a whole bunch of other goofy ones. Those goofy methods come by the fact that every class extends the big O object, okay? If we go look at the documentation for big O object, here's the Java API docs, and we'll run down until we find capital O object, not with the S, that guy right there. It says this one's the root of the class hierarchy, and if we scroll down a little bit, sorry, I got some of it slightly cut off. There's all of the methods that are built into object already. And notice the one that we have used, there's the equals method, right? So the default equals method, if you look at it, is the one that says compare or check by addresses. The addresses have to match. So that's built in so that you get the most restrictive form of the same as you possibly can. And there's our friend toString. as another one. So that's why when you just print out toString without ever writing it, you get the address, because that's the only thing that it knows. And so when we write our toString, that's why we had to write exactly the same signature on our toString. It had to look exactly the same because we were trying to hide one of the ones that was already there, because we were extending the big O object that already had that thing built in. Okay? And so now you know the true meaning of add override is, oh, this thing exists someplace in a class below me. I've already got it within me, and when I write that add override, I'm trying to hide the one that's already there with my own.
So when Eclipse auto-generates a bunch of method stubs, like when you implement an interface or something, and has that override on all those, you don't actually need any of those unless they're in a...
You never have to use the keyword, that annotation at override. It's just there to prevent you from making spelling mistakes, basically. Because, if we go back to our example, let me get rid of this error here. In cell phone, for instance, where we let's do pay-as-you-go phone. It's maybe a little better example. Here, suppose that we'd left this thing off and we'd said we thought it was called talk4. Okay, so in this case, when you write that thing, it's just a different method with a different name. So the compiler has no way of knowing that your intention was to try to hide the talk that's already there. But when you put add override on the top of it, now you're giving the hint to the compiler that says, I'm planning on hiding one that should already be there, and now the compiler is going, you didn't. Okay? And so now it's just saying there is nothing called talk time below you, so you chose the wrong name.
So it's more like informing the compiler that you're intending to...
Yeah, it's exactly that. It's just a heads up on your intention, and so now the compiler knows, oh, well, your intentions are wrong, and when you get the name of it right to what's actually below you, then it goes, oh, okay, that's fine. Okay, so yeah, it's nothing more than a hint to the compiler to let it help you write things. Okay, so now you've learned everything you need to know about Java inheritance in a nutshell.
I thought of another example you could possibly use.
Okay.